Hello. The purpose of this video is to explain how to do regression with Microsoft Excel and do it with crunchit. So very first thing I want to do is I want to show you how you run regression on Microsoft Excel. It did crash the first couple of times, so hopefully it won't crash this time. So we'll see what's different. And we look at our file right here. And this file right here is taken from example 5.4. And what's going on is we wish to see if surface temperature of a body of water explains growth of a particular plant that's in the water. This is example from chapter 5, I believe is example 4. Now, in order to do this, if you go to data right here, go to data, you have to have the data analysis pack like that installed. I went over in a previous video how to install it. So let's click that on. And what you do is you look for the regression thing in this dialog here, and there's a whole bunch of them. You go down to regression and hit OK. Hopefully this won't crash. Now, the first thing you realize is that I put labels here. And what that tells it is that in the first row, the computer knows that not to try to do calculations with this. It says that the numbers are going to be everywhere else. Now, the first things, the Y range is always going to be your response variable, like so. Your input X range will be your explanatory variable, what goes on the X axis or the horizontal axis. Now, there's all sorts of little things that you can put on here. So I'm just going to stick with a basic regression. And I'm also going to make sure that the regression goes to a new worksheet. And let's see, this goes without crashing. And yes, it does. So we'll go to this format so you can read this a little better. And this is your regression. Now, if you take a look, you see the coefficients? The coefficient right here, that tells you that's what goes in front of the, you know how it goes y equals mx plus b? Well, that's going to be your m, your slope. This is going to be your intercept, okay? And what these things mean, we may or may not get to them in this course, but basically a small value in this column indicates that there probably is a linear relationship, that surface temperature really does explain the growth. And then the other thing I want to mention is that this R right here, it's called multiple R. Well, that's going to be our R. That's a regression coefficient. And we see the regression coefficient is 0.88. 0.81. So that indicates that there is a relationship between those, a linear relationship, and it's 0.8 is pretty high. In class, we'll go over what this R square means, but basically what it is that if you look at a scatter plot of the data, the response variable is going to have some variation in it. It's going to have some scatter. And this basically it tells you how much of the scatter in the response variable is explained by the scatter of the X variable, or basically how much of the variation is determined by the line. Now, what I'm going to do here is I'm going to take a risk, see if it crashes, and it might. It crashed the last time. I'm going to do another regression. Same thing, but then I'm going to try to put in a fit line plot. See how that works, goes. And yep, it's crashed, so I know better than to do that with Microsoft Excel on this computer. It's an old one. It did its best, but that's another lesson. Now let's go to crunchit. And crunchit, I'm going to go ahead and do that. All right, so we're at crunchit, and let's file-wise, let's import from chapter 5. And I believe is example 5. Nope, that's not what I want. So we're going to import here, chapter 5. Sample 1. Nope, that's not what I want. Let's see here. Had it just now. Sample, maybe it's exercise 4. Yeah, there we go, exercise 4, my bad. And we see there we have the surface temperature and we have the growth. All right. Now, in order to figure out the regression, you go to statistics, hit that, and you look for regression and you see this. Now, what we want is simple linear regression. The other two things, multilinear regression is what happens when you have a single response variable, but two different or two or more explanatory variables. Logistic regression is when you're trying to fit maybe a different kind of curve. Right now, we're going to use simple linear here. You click that. The dependent variable is going to be, in this case, going to be your growth. The dependent variable is your response variable. The independent variable is going to be the temperature. And these other things, let's see what display we wanted. Let's go ahead and do a fitted plot and see what we get here. And we see right here that this blue line is the regression line, and these dots are the data points. Now, I'm going to go ahead and actually come up with the coefficients here, but remember when we went through class and we talked about the x, y, i's, that, well, the x value, this value, the value on this horizontal axis and the vertical axis paired together, those are the xi's and yi's. What's on the blue line are right underneath here, or maybe above in this case, are the yi hats, what's predicted. So if we go back now and do a regression, and this time instead of simple linear, and let's say we want to, instead of a fitted plot, let's just figure out what the numerical results are, calculate, and we see our equation here. And we see that the fitted equation looks something like this. Notice, though, we don't have the R in this case. That's what this looks like. And this minus 0.1579 is this number here. So we can see this going down. And to see the correlation, let's go to the, let's see here. Let's go ahead and go to statistics and let's see the R. That's the correlation. So these are the two things we're correlating, calculate. When we see the R is minus 0.8111, that basically means this thing is going down like this. So that's how you do a calculation here with crunchit, right? So thanks for watching, and I'll see you in class.